Hi everybody. So in this video, we're going to look at the expectation and the variance of a geometric distribution. So we'll work through example 1 and example 2, and then we'll try 2 exam style questions. And if you want to work along with me, I'll leave a link to the PDF below. Okay, so we're going to use these formulae, and these are provided in the Edexcel formula booklet. This is where if x is distributed geometrically with a probability of success p, then the expectation of a mean of that distribution is 1 over p, and the variance of x, or the standard deviation squared, is 1 minus p over p squared, okay? In this video, I'm going to show you how to use them rather than how to prove them. So in example 1, we're told that the random variable x is distributed geometrically with a probability of success 0.2, so this is p. We're going to have to work out its expectation and its variance. So the expectation of x, substituting in p into our equation here, will be 1 over 0.2, which is 5. So to understand what this expectation of 5 tells us, if we have a fair 5-sided pentagonal spinner, and we wanted to look at the probability of getting a 3, when this would be 1/5 or 0.2, we would expect to spin this spinner 5 times our expectation in order to get a 3 once. If we spun it 10 times, we would expect to get 2 3s. 15, we would expect 3 3s. So this is our expectation. And the variance of x, well, we have p of 0.2. We can substitute that into here. So we get 1 minus 0.2 over 0.2 squared. So 0.8 over 0.2 squared, which will give us 20. What the 20 tells us is that the square of the average distance from all our data points from the mean would be 20. So I hope that's given you an idea of what the expectation and the variance of a geometric distribution actually tell us, rather than just being able to calculate it. So for example 2, we're told that x is distributed geometrically with a probability of success p, and its expectation is 4. So 4 will be equal to 1 over p. So 4p will equal 1, p will equal 1/4. And then for the probability of x equaling 6, this means we would get our first success on the 6th attempt. So the 5 previous goals would have been a fail, which is the probability of 3/4. That would have been 5 successive fails, followed by 1 pass. And we can work out this on our calculators, and the 4 decimal places, we get 0.0593. Okay, let's try example 3. So in example 3, we're told that the fair 3-sided spinner has sectors labelled 1, 2, and 3. It is spun until a 3 is scored, and the random variable x is the number of spins required to get a 3. If you want to try parts A, B, and C yourself, you can pause the video, and when you come back, we'll go through the solutions. Okay, so welcome back if you had a go. So we'll state our model that x is distributed geometrically with a probability of success 1/3. Then for part A, the probability of getting our first 3 on the 4th attempt. Well, attempts 1, 2, and 3 would have been a fail. And if 1/3 is a pass, then 2/3 must have been a fail. And this would have been 3 successive fails, followed by the final success. And this will give us 8 over 81. Part B, the expectation of x will be 1 over 1/3, which is 3. So you'd expect to spin this spinner 3 times to get your first 3. And then for C, the variance of x will be 1 minus p over p squared, which is 2/3 over 1/9, which is 6. Let's try our final question. For example 4, Liam is practicing archery and records the number of attempts X he takes to hit the target each time. Given that each attempt is independent and that the variance of X is 20, we would ask to find the probability of success and the expectation of X. So do you want to try this question yourself? So we'll set our model that X is distributed geometrically, the probability of success P, and then to find P, we can use the variance. We'll substitute that into here. So 20 will equal 1 minus P over P squared. So we get 20P squared. We'll move a 1 and a negative P, so plus P minus 1 will equal 0. We can factorize this and we get 4P plus 1 and 5P minus 1. So from this one, P must be equal to negative 1/4. And then from this one, P must equal 1/5. But we know that a probability cannot be negative, so we can discard this value of P. So then for part B, the expectation, this will be 1 over 1/5, which is 5. Okay? Well, thank you very much for watching. I hope you found that useful. And you can download the full lesson and a copy of a PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.